This is the video for sections 2.4 and 2.5 on special pairs of angles and perpendicular lines. So first we're going to look at some special types of pairs of angles. The first pair of angles that we're interested in are complementary angles. And complementary angles are two angles whose measures add up to 90 degrees. If you have two angles that when you add up their measures you get 90 degrees, those angles are called complements of each other. They are complementary angles. So in this first picture, angle XYW and angle WYZ are complements, because when we add up their measures, 40 degrees plus 50 degrees, we get 90 degrees. Two angles do not have to be adjacent to each other like those angles are in order to be complements. In this triangle on the right, angle R and angle T are still complements of each other because 60 plus 30 equals 90, even though they are not adjacent angles like the angles in the first picture were. So angle R and angle T are complements, and we can say that because the measure of angle R, notice the difference in notation when we're talking about the measure of an angle versus the angle itself. The measure of angle R plus the measure of angle T equals 90 degrees. Since they add up to 90 degrees, those angles are called complements of each other. Okay, if two angles add up to 90 degrees, they're called complements. The other number we're interested in angles adding up to is 180 degrees. And we call angles that add up to 180 degrees supplements, supplementary angles. So supplementary angles are two angles whose measures add up to 180 degrees. So they add up to being a whole straight angle. In this first picture, angle C, which is 40 degrees, and angle D, which is 140 degrees, since 40 degrees plus 140 degrees equals 180 degrees, angle C and angle D are supplementary. They add up to 180 degrees, so they are supplementary. In the picture on the right, we don't know the measures of the angles. We called the measure of angle DEG X degrees, and we said that the measure of angle GEF was 180 minus F degrees. Since when we add them together, we get X plus 180 minus X, and the X's cancel and we just get 180 degrees, then those angles have to be supplementary. So angle DEG and angle GEF are supplementary. We could say they are supplements of each other. Okay, so we have complementary angles, two angles whose measures add up to 90 degrees to a right angle. We have supplementary angles, angles whose measures add up to 180 degrees to a straight angle. Our other pair of angles are called vertical angles. Vertical angles are two angles such that the sides of one angle are opposite rays to the sides of the other angle. If you remember back to last week, we said that opposite rays are rays that have the same endpoint but point in opposite directions along a line. So two angles are vertical angles if their rays are opposite rays of each other. In this picture here, angle 1, this angle, and angle 3 are vertical angles because the sides of angle 1, which I'll highlight here in yellow, those are the sides of angle 1. Those are opposite rays to the sides of angle 3, which I'll highlight in blue. Okay? This ray has this one as an opposite ray. This ray has this one as an opposite ray. Since their sides are opposite rays of each other, those angles are vertical angles. So angle 1 and angle 3 are vertical angles. And we have another pair of vertical angles in this picture. Angle 2 and angle 4 are vertical angles. Because the sides of angle 2, which are these, are opposite rays to the sides of angle 4. The ray opposite this one is this one. The ray opposite this one is that one. Since the rays of angle 2 are opposite rays to the rays of angle 4, angle 2 and angle 4 are vertical angles. So anytime two lines intersect, they form two pairs of vertical angles. And it will look just like this picture here. Those angles will be sort of opposite of each other on the picture. So anytime two lines intersect, they form two pairs of vertical angles. Vertical angles, as you can kind of tell by the picture, are always equal in measure. They're always congruent. And that is our first theorem for today. Vertical angles are congruent. They are equal in measure. Here is how we're going to do a proof of this. A theorem, if we're going to prove it, always gives us some information, and we call that information the given. The given is always essentially the hypothesis of our theorem. That is, that we have vertical angles. So our given is, in this case, angle 1 and angle 2 are vertical angles. We have a pair of vertical angles. What does our theorem say has to be true about those vertical angles? They need to be congruent. So that's what we're trying to prove. That angle 1 is congruent to angle 2. If we can do that, then we have shown that this theorem is true, no matter what pair of vertical angles we have. Because all we're doing is starting with a generic pair of vertical angles, angle 1 and angle 2, and I've drawn a sketch of them on the left there. And I'm showing that if I have that pair of vertical angles, or any pair of vertical angles, those vertical angles are equal in measure. They are congruent. Okay. Remember, our first statement is always what we are given. So angle 1 and angle 2 are vertical angles. our first reason, given. That's given to us in the problem. Okay. Second statement. If we look at the picture, what do we know angle 1 plus angle 3 add up to? Since those two angles are adjacent to each other and together they form a straight angle with that line, then those two angles have to add up to 180 degrees. What tells me that they add up to 180 degrees? What tells me that when I add up two adjacent angles I get the whole angle? That, remember, is the angle addition postulate. That when I add up two adjacent angles, I get their whole angle. Okay? Now angle 1 plus angle 3 add up to 180 degrees. But I have another pair that adds up to 180 degrees. Angle 3 plus angle 2 add up to 180 degrees. And for the same reason. The angle addition postulate. Okay? Those equations both equal 180 degrees. So I could combine the two equations together, replace 180 degrees in the first equation with angle 3 plus angle 2. Angle 1 plus angle 3 equals angle 3 plus angle 2. Why can I replace 180 with angle 3 plus angle 2? What allows me to do that is the substitution property. Since 180 degrees is the same as angle 3 plus angle 2, I can replace them. Okay? If we look at that equation in number 4, angle 1 plus angle 3 equals angle 3 plus angle 2, there's an angle 3 on both sides of the equation. And I know I can always subtract the same thing from both sides of an equation. That means I can write that angle 1 equals angle 2 because I can subtract the same thing from both sides. That is called the subtraction property of equality, or POE. Remember, our properties of equality tell us what we can do to both sides of an equation. Alright, my goal was to show that angle 1 is congruent to angle 2. I've just shown that angle 1 equals angle 2. All that remains is to state that angle 1 is congruent to angle 2. Why do I know that they are congruent if they are equal? Because that is the definition of congruence. Two things are congruent if they are equal in measure and the same shape, but these are both angles. So I've shown that if I start with a pair of vertical angles, I end up with those angles being congruent. So that is always true no matter what vertical angles I start with. Okay. Now that we've proven that, we can use it whenever we want. Alright. Let's talk about perpendicular lines. Perpendicular lines are two lines that intersect to form right angles. Right angles, remember, are angles equal to 90 degrees. If we look at the picture on the right there, line JK and line MN intersect each other. If I know that, say, if angle 1 equals 90 degrees, then I know line JK is perpendicular to line MN. That symbol I just wrote there means perpendicular. So if you want to say that two lines are perpendicular, you write the two lines and put that symbol in between them. Okay? So if two lines form right angles, those lines are perpendicular. So I have a question. How many right angles do perpendicular lines form? Well, if they form one right angle, if angle 1 is a right angle, which on the picture we always use a little box to indicate that that is a right angle. If angle 1 is a right angle, well, we know vertical angles are congruent. Angle 3 is a vertical angle to angle 1, so that also has to be 90 degrees, so it also has to be a right angle. But angle 1 and angle 2 have to add up to 180, so angle 2 also has to be a right angle. And angle 3 and angle 4 have to add up to 180, so angle 4 also has to be a right angle. So how many right angles do perpendicular lines form? They form exactly 4 right angles. Every time. Okay? Now I want you to notice something. If two lines form a right angle, one right angle, then those two lines must be perpendicular because of the process I just went through. We have vertical angles that are congruent. We have supplementary angles that are congruent. So those 4 angles must all be right angles, which means those two lines must be perpendicular. So if two lines form a right angle, those two lines must be perpendicular. So if you know you have one right angle, you know you have perpendicular lines. Okay, 3 quick theorems about perpendicular lines, and then we'll be finished. First, if two lines are perpendicular, then they form congruent adjacent angles. If two lines are perpendicular, they form congruent adjacent angles. Remember, adjacent angles are angles right next to each other that share a common endpoint, share a common side, and no common interior points. That makes sense because when two lines are perpendicular, they form 4 right angles. Those right angles are adjacent to each other. They're all the same measure. They're all 90 degrees, so they have to be congruent. That's a pretty basic statement. If two lines are perpendicular, they form 4 90-degree angles, so those angles are all congruent. Okay? The other one is the more interesting one. If two lines form congruent adjacent angles, then they are perpendicular. Notice that is in the opposite order of the first statement. In the first statement, our hypothesis is two lines being perpendicular. And our conclusion is they form congruent adjacent angles. In the second statement, our hypothesis is we have congruent adjacent angles. And our conclusion is those lines must be perpendicular. So we've actually, by stating these two theorems, we're saying it goes in both directions. If we have perpendicular lines, we have congruent angles. If we have congruent angles, we have perpendicular lines. Congruent adjacent angles, I'm sorry. If we have congruent adjacent angles, we have perpendicular lines. So in this picture here, if this angle and this angle are congruent, and they're definitely adjacent angles, if they are congruent, let's call this angle 1 and this angle 2, what this theorem is saying is if angle 1 is congruent to angle 2, then the two lines must be perpendicular. Because angle 1 and angle 2 are congruent adjacent angles. It does not work if they're not adjacent angles. And our last theorem, if the exterior sides of two adjacent acute angles, acute meaning they're less than 90 degrees, are perpendicular, then what has to be true about the angles? Let's look at this picture. If the exterior sides of two acute adjacent angles, so that's an angle that's acute, it's less than 90 degrees, it's adjacent to this angle, which is also acute, less than 90 degrees. If their exterior sides, so exterior meaning the side they don't have in common, this side and this side, if those exterior sides are perpendicular, then those two angles must add up to 90 degrees, so must be complementary. Because these two lines are perpendicular, those two angles have to add up to 90 degrees, so they have to be complementary. Okay, here are your immediate practice problems for today. There are 4 of them, but they are all true-false statements. We have this picture, and I'm giving you this very important piece of information. Don't forget this. If AB is perpendicular to CD, then identify each statement as true or false. So I indicated on the diagram that they're perpendicular by putting that red box in there. Number 1, AB is perpendicular to EF. True or false? Number 2, angle CGA is a right angle. Number 3, angle EGC is congruent to angle FGD. And number 4, angle BGF is complementary to angle FGD. Please write down each of those 4 statements, write where they are true or false, and draw that picture on your paper. And that is the end of the video for sections 2.4 and 2.5.